All right, we're going to do dilations with a square grid now. Okay, so let's get involved with that. So we're going to estimate a scale factor. So we would measure point C is the dilation of point B with a center dilation A and a scale factor of S. We want to estimate S here. We're only estimating it, so we don't have to be exact. But we do want to measure from here out to here. And then we want to measure from here out to the same point. So the only thing that I'd be doing is looking at this and going, oh, that looks to be like a little more than twice as long. So maybe my estimation for my scale factor might be 2.5. Don't think it's 3 times as long, but I do think it's more than 2. So I'd say 2.5. So if we measure the distance and we do a better job even measuring it, the only thing that I would encourage you to do is to start maybe on the same side of the dot and measure to the same side of the dots. To there, or the opposite side. Because this dot's so big, you want to pick one side and measure to it. Okay? And we know that the scale factor is greater than 1 because C wasn't on top of B. We know that it's probably bigger than 2, but a little less than 3. So it might be 2.5 or a little less. I think if you actually measure it out using a ruler with centimeters, I think this turns out to be like 2.3. On a grid makes things a lot simpler, a lot easier to deal with. So we're going to perform these 3 dilations, 1 on a rectangle, 2 on a triangle. So we're going to be told that our center is P, so that's where we're going to start every time. So that means over and up, over and down. So this is 1 by 2, whereas this is 1, 2, 3, 4, 5 by 2. And since our scale factor is 2, I want to take these numbers and I want to multiply them by that scale factor. So my new are 4, 2, 10, and 4. So this 1 needs to become 2. So I go from the center out 2, up 4. So this is A prime. C prime now go out 10. So that's 5, 6, 7, 8, 9, 10. And go down 4. 1, 2, 3, 4. That's C prime. You should notice that the line from P to A prime would all be on a straight line. Same thing if you look at P, C, and C prime. They would all be on a straight line. So let's go ahead and complete this for B. B would be 5 and up 2, so out 10, up 1, 2, 3, 4. This would be B prime. D would be left 1, down 2, so go left 2, down 4, 3, 4. So then we end up with this rectangle. That would be our new, this would be our image. The image is A prime, B prime, C prime, D prime. The pre-image is A, B, C, D. So here we're going to do the same thing now with a triangle and our center is not inside it, it's over here at T. So again, we're told the center of the dilation. So you want to come over and up. So you're making this right angle look, this L shape. So that is 1, 2, 3, up 1. So now for our dilation, let's not use blue, choose orange. We would go 6, 3, 4, 5, 6, up 2, and you'll notice that we are on our Q prime is on T, Q, and Q prime all lie on that dashed line. They always should happen that way. So to get to R, so if we're going to do R, again, I'm going to count 1, 2, 3, 4 now, down 1. So then times it by 2, that's 8. So there's 4, 5, 6, 7, 8. Now I go down 2. That would be R prime. So then S, that would be over 2, down 2. So then that would be go over 4, down 4, 2, 3, 4, down 1, 2, 3, 4. So you can see that all of these stay on these diagonal lines. So our new triangle is here. Now what happens if we half it? If we can remember those numbers, we don't have to remember those numbers. We know S was 2 and 2, so that would be 1 and 1. Because half of 1 and 1, half of 2 and 2, sorry, is 1. So I would call this double prime. This was 3 and 1, so we're going to do half of 3 and 1, which is 1 and a half, and we should be on the line. It's not S prime, it's Q double prime. You'll notice T, Q double prime, Q, and Q prime all lie on the same line. Then R was 4 and 1, so we would go 2 and a half. R double prime. So then we draw on our triangle. It's going to be smaller now. So that's how we do those. Okay, you could have on either one of these measured from T to Q, found it in centimeters, took that times 2 and measured out. Just knowing you're going to be on this line, since this was on a grid, you think that would be on a grid. But this was on a grid, and when I went smaller, it wasn't. This was on a grid, and went smaller, it wasn't. So it's not always the case. But you could have done the measurement. How does the scale factor show up in each method? Well, if I took this distance from T to Q and the distance from T to Q prime divided by the distance from T to Q, I would get 2. Same thing from T to Q divided by, T to Q. T to Q prime divided by T to Q. Yeah, it's image over pre-image. So this image over the pre-image, that would give us a half. Answering those questions. On the card sort, you're going to work on this. I'm going to show you the stack of cards here in just a minute. You're going to match each number card showing a figure in the coordinate plane with a letter card describing the image. This is the image, so you got to come up with the image. Okay. So I'll show you the cards. Here's the cards. This will be on your activity. You can open this up. Down here, it'll tell you what the dilation is going to be. So you're going to dilate a trapezoid using a center of -1, -2. Scale factor of, ooh, we got to zoom in on that. Where is zoom in? I don't know where zoom in is. No, that's not what I want. I want to zoom in. See if I can zoom in here. There we go. I think that's 3/2. 3/2. So 3/2, you perform those. You got 2 circles. You got 2 triangles. And then down here, you'll match it up with either A, B, C, D, E, and then F. You got to tell me the coordinates. So one of these cards doesn't match down there because there's 6 picture cards and only 5 with the dilation and everything of it, what it says it is. So this is the image. It's what you're getting. Okay. But then it's a self-check for you. So then you would self-check yourself on that, see what you're at. One of the number of cards will not have a match for this card. You will need to draw an image. So you do it, draw the image, come up with the coordinates. So if we look at a circle, here's a circle. The image of a circle under dilation is a circle when the center of the dilation is the center of the circle. What happens? The center of dilation is a point on the circle. So if I look at this circle, this center is here. That's the center of that. Because it's equidistant from the sides. This is at 8, 0, halfway in between is 4. So all of these points would be 4 away if I looked at that. So then if I did 1.5, so if I took 4 times 1.5, I will get 6. We'll do a green circle. So then it's from 0, 0, this is out 6. So then go out 6. Go up 6. 1, 2, 3, 4, 5, 6. Go down 6. And it is back here. That B stays there. So then you end up with this circle. That's a horrible looking circle, sorry. Something like that. But you get a circle. But its center is at 6 because you took 4 times 1.5. So when you think back to the matching game, you can think of which ones were tricky. Did you make any adjustments in your matches? What might have caused you to make an error? What adjustments did you make? Don't forget, in this section, a dilation maps a circle to a circle, quadrilateral to a quadrilateral, triangle to a triangle. If the center of dilation for a polygon is one of the vertices, then that vertex is on the dilated polygon, just like B was on the circle, it stayed on the green circle. The scale factor is less than 1. The dilated image is smaller than the original. If the scale factor is larger than 1, the dilation image is larger than the original. So we look at this. How we go about dilating this? Well, we would do our L. We want to, how will you dilate Q with the center at P? So this point's not going to move, but Q is. So I would half this distance, 1, 2, 3, 4. So I would come out 2 and go up 1. And this would be Q prime. Now when I get to this one, if I still said the scale factor was a half, let's say we're going to dilate B by A, it'd be a little easier because this is 2 at 2, 0. So then this would be, if I'm dilating this by a half, then it should be right in here at Instead of out 2, up 1, it's out 1, up a half. So this would be 1.5. So B was 2, 1. B prime was 1, 1/2. So I could multiply a half times 2.5 times 1. It's easier to get coordinates. This has coordinates, whereas this other one doesn't have coordinates. We just do the counting of the blocks and then move it. I don't think either one's hard, but definitely coordinates are nice. All right, you can pause this for a moment. See if you can do this one. So if I'm looking from P out to A, I'm going to notice that goes over 1, 2, 3, 4 and down 1, 2. So then I would go over 2, down 1. There would be A prime. B is out 4, up 2. So instead of going down, I would just go up. C is out 1, 2, 3, 4, up 2. So go out 2, up 1. And D prime, out 2, down 1. So that you end up with this shape. Interesting thing to start looking at. What is the area of the blue one? What's the perimeter? What's the area? And then what happened to the perimeter in the area? Remember, we can just count area. So that's 8. So I wonder what the area of the blue one is, if the red one is 8. The perimeter is 4, 5, 6, 10, 11, 12. We just add 4 plus 2 plus 4 plus 2. So what happens over here to the blue one? Is this 24? Is this 16? I don't know. I'll leave that up to you to find out.